Hello, today we are going to be conquering Chapter 5, Section 9. We'll do a quick review from yesterday. I would like you to write the parallel line to y equals negative 3/4 x minus 9 through the point 8, negative 12. When you get done with that, I would like you to write the perpendicular line to y equals 4x plus 5 through the point 4, negative 3. Go ahead and hit pause. When you are done, come on back. All right, so the parallel line would have the same exact slope, so none of this is necessary. If the slope is negative 3/4 and it's going through this point, probably the easiest way to figure out the b is to plug y, m, and x into y equals mx plus b and then solve for b. So this is our x, this is our y, this is our m. So negative 12 goes in for y, negative 3/4 goes in for x, 8 goes in for, or 3/4 in for m, 8 goes in for x, and b is what you're solving for. Anything in the numerator can cancel with anything in the denominator. So we have negative 12 equals negative 6 plus b, and then you would add the 6. So b is negative 6. So your equation is the slope, which is negative 3/4 x plus negative 6. You could also put minus 6. The perpendicular line means the slope is the opposite reciprocal. So 4's opposite reciprocal is negative 1/4. None of this is necessary. So we have a slope of negative 1/4 through this point. Same exact process, y equals mx plus b. If you don't like this process, you can use a table and work your way back to 0. 1/4 negative isn't that horrible to work with. And your x is 4. I'm going to put 4 over 1 just so no confusion. You're going to cancel any numerator with any denominator. So negative 3 is equal to negative 1 plus b. And when you add 1 to both sides, b is equal to negative 2. So your equation has this slope, this b, y equals negative 1/4 x plus negative 2. You could also write negative 1/4 x minus 2. That is also the same. And this one doesn't have any weird lines. Talk about transformations in this section. So I'm going to give you the first function, f of x equals 2x, and the second function we'll write as g of x equals 2x minus 6. Now both of these have the same slope, but one of them starts at 0 and one of them starts at negative 6. So if you put this in a graphing calculator, that might be the best way to see it. And if you're following along on your graphing calculator, to clear the memory is second plus 712. Then you go to y equals to type these two equations in. The first one is y equals 2x because it's f of x. The second one is 2x minus 6. And if you look at a graph of both of those, this graph is from 0 to 10, that's 2x, and 2x minus 6 is literally just shifted down 6. So the transformation of this means down 6. If you want, you could make tables of each. So this would be 0 giving you 0, going up by 2. And this would be 0 giving you negative 6, going up by 2. So it'll always be 6 below the first one. Okay, let's look at f of x giving x plus 4 and g of x giving x minus 2. What do you think the transformation is going to be in this? It's also going to be down 6 because the first one starts at 4. Oh my. And the second one starts at negative 2. So it's literally going to look exactly like the last one, but one of them is going to start at 4, the other at -2. So a down 6 shift. Your shift, you're looking at the y-axis and where it's moved on the y-axis. All right, what if we have something like y equals 5x and y equals -2x plus 5? How do you think that transformation is going to look? So let's go back to the calculator. I've already cleared the memory, so it's basically graphing from -10 to 10. So we can just write in the two equations, 5x and -2x plus 5. Remember, the negative is the very bottom one. Okay, what's going on? And if you hit graph, go ahead and think for a second. The first one's going to start at 0. The second one's going to start up 5. But the slopes are different. One is a positive slope of 5. That's what you're looking at right there. The second one is a negative slope of 2. So it's flatter and it's negative. So this is twisted. It's a twist. So it's not even a perfect reflection. It's shifted up and it's completely rotated to be negative. So this part is up 5, and from here to here is a twist or a rotation. So it's turned. The slopes are different. And there's also a reflection, and that's if something is completely negative. So think about y equals 3x and y equals -3x. And if you graph both of those, we'll clear these again. So I'm going to put the -3x on the bottom and put the 3x on top. So the first one graphed is going to be the 3x. It should be positive, going up, and the second one is -3x. And that really looks like a reflection over the x-axis. Whoa, can't write on that, which is the side-to-side one, as well as the y-axis, which is the up and down one. Really, either of them, you could say, is that typical reflection. So we'll put reflection. And a reflection you can think of as a flip. This one is not shifted up or down because there's no B. So no B, so not shifted up or down. All right, so I'll just give you a couple to practice here. How does y equals 4x compare to y equals x? And this one is going to be less steep. How does x minus 1 compare to x plus 6? You're going to have shifted from -1 as a starting point to 6, so it's going to be up 7. How does 1/5 x, that's a 5, compare to 2x? So this is going to be steeper. And these steep ones are rotations. This is called a translation. And what about y equals 7x to y equals -7x? And that is a reflection because it goes from either the x-axis flip or the y-axis flip since it goes through 0, 0. We'll just put reflection. Okay, we're also going to touch on what's in the extension, and that has to do with the absolute value graphs, and it's still just talking about the transformations in regard to the absolute values. So if you have something like the absolute value of x, basically if you start at 0, you get 0. 1 and negative 1 both give you 1. 2 and negative 2 both give you 2. And the graph, the parent function, the basic graph where there's no shifting, is right here at through 0, 0, going up linear at a slope of 1. So if you have something like the absolute value of x plus 5 on the outside, well, this one, if you plug 0 in for x, you will get 5. 1 and negative 1 will still give you the same answer, and that's both 6. 2 and negative 2 will give you the same answer of 7. So this graph is shifted up 5, still the perfect V. Up 5 is that shift. What if you have something like y equals the absolute value of 3x? So that's going to be steeper. Still 0, 0 is where everything starts. 1 and negative 1 will both give you 3. 2 and negative 2 will both give you 6. So 6 is even above that 5. So steeper. Oh, S-T-E-E-P-E-R. Steeper. And that is the rotation. It's rotating to be steeper. And a tiny bit trickier is if you have, I'll squeeze it in right here. Y equals the absolute value of x plus 2. In this case, the thing that makes the middle part 0 is negative 2. So negative 2 is what gives 0. Therefore, the symmetry is going to be on either side of negative 2. So negative 3 and negative 1 would both give you 1. And then negative 4 and 0 would both give you 2. So this starts at negative 2, 0. Oh boy. And then goes up perfectly. So this is a translation, a slide left 2. So when you add 2 right there, it is translated left 2. So when in doubt, you can always put these in a graphing calculator and just sort of see what the translation is from the base of 0, 0, the parent function. I hope I talked fast enough for you. Have a lovely evening.